So good morning everyone and welcome to the class on test of hypothesis where we'll discuss a one mean z test problem. So you can see this problem. Question number one, there's a company called Hilton Press, and this company is claiming that the average life of their largest web press is around 14,500 hour. That is the claim of the company. We don't know this is true or false. So they know that the standard deviation of the press life is around 2100 hours. So here population standard deviation is given to you. So whenever the population standard deviation is given to you and n is more than 30, we perform z test. But even then, before we do that, let's try to read the further lines of the question. So from the sample of 25 press, the company find that here the n is 25. The company find that the sample mean of 13,000 hour, and at 1% level of significance, should the company conclude that that the average life of the press is less than the hypothesis, the 14,500 hours. So here you can understand, here in this problem you can understand that what they're asking you with the analysis what you need to perform, where you need to prove or disprove that is the average life of the press is less than the 14,500 hours. So I told you, you do one tail test whenever when you are working on the test of hypothesis, when you have to do more than or less than. So here when we are solving the problem, first we write a null hypothesis. So first we'll write null hypothesis. So here null hypothesis we write as mu is equal to 14,500 hour, whatever is given. So that is the statement of company. In null hypothesis, we assume this to be true. So then, like you can write the life of the average life of the web press of Hilton Press, of average of Hilton Press. The company name is Intel Press is equal to is equal to 14,500 hours. So whatever is given, we consider that to be true in null hypothesis. Then I'll write alternative hypothesis, where in alternative hypothesis, whatever the last line of the question is given, here it is given that should the company conclude that the average life of their web press is less than 14,500 hours. So here you write mu is less than 14,500 hours. So then in alternative hypothesis, you'll write that the average life of the web press, average life of the web press of Hilton Press Company, the name of company is Hilton Press, is less than less than 14,500 hours. Less than 14,500 hours. So you can understand, because in this problem they are mentioning the term called less than or more than. So we work on one tail test. So this is the problem of one tail test, and here they use the term less than. So this is left-handed one tail test. Imagine if they would have used the term greater than, then it would have been more than or right-handed one tail test. So I hope you understood. In the last class, I have given you brief introduction to understand when the problem is about one tail test and when the problem is about two tail test. Next thing you need to understand, is this a problem of Z test or T test? So we perform Z test when the population standard deviation is known to us, and if the population standard deviation is not known to us, then we perform T test. So in both in P test or Z test, we work on normal distribution curve. Only thing in the case of T test, we look data in the term of degree of freedom, where the degree of freedom will be n minus one. So here, if you see this problem, here, your n is equal to 25. If you see this problem, your n your n if you see this problem, in this problem your n is equal to 25, okay, and the population standard deviation is given to you is 2100 hour, 2100 hour, okay. The population standard deviation is given to you as 2100 hour, okay, and the sample mean is 13,000 hour. The sample mean is 13,000 hour. The sample mean is 13,000 hour, and population mean is 14,500 hour. So you can understand everything is given in this problem. You can see whatever is given in the data, whatever is given here in the data, this will be the population mean. This is 14,500 hour. This is called as population mean. This is called as population mean. Okay, and when you to prove or disprove the null hypothesis, you collect the sample, and the mean for the sample is called sample mean, which is given here is 13,000 hour. This is the sample mean, that is 13,000 hour, that is given to you. Sample mean, which is 13,000 hour. The n here is 25. The n here is 25, and the alpha is 1%, n is 25, okay, and the standard deviation which is given, population standard deviation, is 2100 hour. All this, I hope you understood this. Now what you need to do, you need to find the calculated z value. You need to find the calculated z value. So the calculated z value formula is x bar minus mu divided by sigma by root n. This is the formula what you use, where you use this formula to solve this. So x bar is 13,000 minus mu is 14,100 divided by sigma. Sigma is 2100 divided by root n. N is 25. So you can find this. This will be 30 minus 1500. 14,500 minus 13,000. 1500 divided by 2100 by 5. You can solve this. Minus 1500 divide by this is 420. Okay, so you can solve it further. This is minus 5 minus 50 by 14. So you can solve this. Minus 14 threes are 42, right? 14 threes are 52, 42, yeah. 14 threes are 42, 14 fours are 56. So 14 threes are 42, then 80. 80 means 5s are 14, 5s are is 70, then 100. 100 means 100 14 6 is 84, 14 7 14 7 is 128, 14 7 is 198, sorry. So 14 7 is 98, then 21. So around minus 3.571 you will get. So minus 3.571 you will get the value. So minus 3.571 you will get the value. So your calculated z value is minus 3.571. Okay, this is your calculated z value. So this is the formula what we use for the calculated z value. So this value, whatever the z value you get, you compare this with the theoretical z value. You'll compare this with the theoretical z value. We'll compare this with the. We'll compare this. You know that in test of hypothesis, whenever we work on test of hypothesis, whatever the value we get, we need to compare that with the theoretical value. So your theoretical z value you need to calculate. So whenever you calculate your theoretical z value, if your calculated value is less than the theoretical value, then you will accept the null hypothesis. Otherwise, you will reject the null hypothesis. Very simple. So now we'll calculate the theoretical z value. So if you understand, this is one tail test problem. This is left-handed. This is left-handed one tailed this is left-handed one-tailed uh, Z test. If you understand, this is one-tailed test. Why? Because I told you already from beginning. Then how to understand one-tailed or two-tailed, depending upon your alternative hypothesis. So and here the alpha is given to you 1%. I believe so. Alpha is given to you as 1%. So what you do? So you simply draw the normal distribution curve. You know how to draw a normal distribution curve. You know that 50% of area will lies on left hand side, 50% of the area will lie on right hand side. Already I did when I was discussing normal distribution curve. So 50% of the area left hand side, 50% of area is in right hand side. This is your rejection region. This is your rejection region. Okay, this is your rejection region. If your data lies in this region, you will reject the data, and this is your acceptance region. This is your acceptance region in the normal distribution curve. You know normal distribution curve. 50% of area lies on right hand side. 50% of area lies on the left hand side. Okay, so you know this now. What is your value of alpha? Alpha is 1%, right? Alpha is 1%. So if you alpha is 1%, so alpha significance region alpha is 1%. So this is 0.01. Rejection region is 0.01. So your acceptance region will be how much? It is simple. So this will be 0.49. Very simple. So if your rejection region is 0.01, then your acceptance region will be 0.49, because total area left hand side is 0.5, total area on right hand side is 0.5. And this, because this is you can understand here less than term is there. So you will see left hand side of the graph or the area curve where you put the rejection region as 1% on left hand side. So that 1% is 0.01. So the acceptance region would be 0.49 on left hand side. I hope you understand. Very simple. So now what you need to do? So you need to find now determining. Now what I need to do? I have to find determining the z value. I have to determine the z value corresponding to the area. I'll determine the z value corresponding to the area. What area? Of 0.49 in normal distribution curve. So I'll ask for normal distribution curve from the examiner, and I'll see in normal distribution curve. What I'll see normal distribution curve and area of 0.49. So I'll see normal distribution curve and area of 0.49. So you can ask for normal distribution curve, and you can see for an area called 0.49. So see here where you're getting a value called 0.49. You can see the value where you're getting a value called 0.49. You can see this is the value 0.49. I hope you can understand. I can't write here, so I hope you can understand. This is 2. This is 2.3. This is 2.33. You can see the area. So the normal distribution, that is 2.33, where you're getting a value of 0.49. So at what value at normal, you can ask for an examiner normal distribution curve. You can ask for examiner a normal distribution curve, and when you ask from examiner normal distribution curve, in that normal distribution curve, see the area called 0.49. So where that value 0.49 lies under the normal distribution curve. So the point where the value 0.49 lies, that gives a z value, of 2.33. So here, because we are doing left-handed test, so I'm putting minus sign here. So you should get a value. If your calculated value is less than 2.33, you'll accept the null hypothesis. Otherwise, you'll reject it. You can see this. This is 3.571. So you can, here the acceptance region is only 2.33. So you can understand this. Now you can see the calculated z value, what you can get. is 3.571. You can see that it is 3.571, while your theoretical z value, what you're getting, it is around 2.33. It is around 2.33. So since the calculated z value is more than since the calculated z value is more than the theoretical z value, since the calculated z value is more than your theoretical z value, so it means we do not accept the null hypothesis. It means we do not accept the null hypothesis. So if we are not accepting the null hypothesis, what that mean if you do not accept the null hypothesis, it means that the average, it means what? It means the average life of web press. It means the average life of web press of Hilton press is less than 14,500 hours. So whatever is given, so 14,500 hours. Whenever we talk about one tail test, for one tail test we have one rejection region. So by reading the last line of the question, we need to understand, is this is a problem of one tail test, or is this is a problem of two tail test. So once we are clear with the it is a problem of one tailed or two tailed, in one tailed you get two kind of situation. Either your problem require you to do right-handed one-tail test. When you do right-handed one-tail test, it is more about a greater than, increase, or above, something like synonyms will be given. And whenever you have to perform less than one tail test, then it would be less than or lower or decrease. So once you understood that you have to do one tail test, then you need to understand in one tail test you have only one rejection region. So you have only one rejection region. So here the alpha is given 1%. In the problem, alpha will be given to you. In case if the alpha is not given, alpha is means level of significance. You remember type 1 error, alpha, beta. So type 1 error, so rejecting a null hypothesis when it true. So alpha is the parameter which measures the type 1 error. So alpha will be given to you in the problem. So you need to do this test at 1% level of significance. So 1% will be your rejection region. So this region is your rejection region. This region is your rejection region. If your data lies in this region, you'll reject. And what is the value, or what is the area corresponding to that? 0.01. Now you know that 50% lies on left hand side. This region is zero point 0.5. You know that this region is zero point 0.5. You know that this region is zero point 0.5. You know that this region is zero point 0.5. You know that this region is zero point 0.5. Okay, and you know that this region is zero point 0.5. 0.01 already is there in this part. This is 0.01. So how much is your acceptance region? 0.49. Simple, guys. So this is 0.49. Once you get this value, 0.49, once you get this value, call 0.49, then what you do, you'll ask from your examiner a normal distribution table. You raise your hand, ask examiner normal distribution table, and then under the normal distribution table you see where you are getting a value called 0.49. See a normal, or you do one thing in your mobile or your laptop, open a normal distribution table. Please don't simply look it here. Open a normal distribution table, and there in that you see where there's a value called 0.49. So you can see this value called 0.49. You can see this value called 0.49. You can see this value called 0.49. You can see this value, it can't become more smaller. So you can see the value called 0.49. You can see this value called 0.49. So 0.49 If you see a value called 0.49 corresponding to what value? So that is 2.33. So you see the value 0.49 that correspond to 2.33. So that 2.33 is your theoretical z value, and whenever you're solving the problem, in that problem, you calculated z value what you're getting, that should be lesser than 2.33. If you are not getting lesser than 2.33, means if you are getting a value bigger than 2.33, it means that you have to reject the null hypothesis. So this is what we need to do here. Anyone, any doubt? Now the same problem I can do in other way also. Now the same problem, you have to draw diagram also. So the same problem, there's another way also I can solve the same problem. So method two, to get the answer for the same problem. So what you can do, you can draw the normal distribution curve. You draw the normal distribution curve. This mu is how much? 14,500. Okay, this is your mu. Okay, and you have an acceptance region. You have an acceptance region. So this correspond to 0.01. This correspond to 0.49. All that you know. 0.49 means what? 2.33, right? 0.49 means what? That correspond to what z value? 2.33, right? So now what you need to understand here, so this value, so the value till where you'll accept the answer, the value till where you'll accept this answer, like this is a barrier. Beyond this you have rejection region, beyond this you have a rejection region, and this is your acceptance region. So the barrier value, if you want to determine, that is nothing but you can, that would be mu plus minus 2.33, because 2.33 is your area of acceptance, into sigma by root n. Sigma by root n is your standard error. So this is your value till where you can accept. Mu is 14,500 plus 2.33 into sigma. Sigma is 2100, right? And root n, n is 25. Sigma here is 2100, right? Yeah. So you can solve this. So plus minus. So basically, plus minus we use for two tail test. For one tail test, we use either plus or either minus. So this is 14,500 plus minus, because here we don't have a two region. Here we have only one region. So this is 2.33 into 2100 divided by 5. So I can say x is equal to 14,500 plus minus, then 2.33 into, this is what, 420, right? So this is 420. So you can say x value 14,500 plus minus 2.33 into 420. So 2.33 into 420. So you can solve this. This is 664 and this is 1239. So this is 6879. Then you put 0 and then 2 decimal. So 978.6, 978.6. So 978.6. So you will get the two region. So you get the two region, 14,500, then 978.6. This is 4, this is 1, 92, this is 5, 13,521. So 13,521.4. And you can, if you want, you can find that side value also, plus value also. But because we are doing this left-handed one tail test, so there's no point of finding the right hand side value. You can I hope you are understanding. So 14,500 and then 978. So this is 478.6. So you can understand this. So imagine if your sample value, if now you can see the your sample value. So this, if you look into your normal distribution curve, if you look into your normal distribution curve, your mu was 14,500 hour, okay, and the maximum value what you can accept is 13,521.4 value. Okay, so if your sample value lies between 14,500 to 13,521.4, you will accept the null hypothesis. Where is your sample value? Sample value is 13,000. What is the sample value? It is 13,000. I hope you're understanding. So if you see your sample value, where is your sample value? Where your sample value lies? If you see your sample value is 13,000, and 13,000 lies in the rejection region. So this is your acceptance region. So this is your acceptance region. This is your acceptance region. So if your sample value, if sample data, if sample data, the sample mean, if the sample mean is between 13,521.4 to 14,500, we'll accept the null hypothesis. We will accept the null hypothesis. So I hope you understood this. So this is the other way to solve the problem. So this is the other way to solve the problem. So whatever way you do, you can get the same answer. So two methods are there. Different books and statistics, when you refer, they will solve the same problem by any of the two methods. So you need to understand which is more comfortable for you, and with that you can do it to get the answer. Now we'll do the next problem, question number 2. So at the end of the class, I'll give you the other questions. If you want, you can do them. All this question will be forwarded to you. So now you see the next question. Now you can see the next problem. So question number 2, American theaters. So you can see this: American theater knows that the certain hit movie run an average of 84 days in each city. So mu here is 84. Okay. And the corresponding standard deviation was 10 days. So the population standard deviation given means you do Z test. So this unit is days. So mu is 84 days, sigma is 10 days. The manager of Southeastern District was interested in comparing the movie popularity in his region with that of America other districts. So he randomly chose 75 theater. So N is 75 here in his region, and found that they run an average of 81.5. So the X bar is 81.5 days. Okay. So state an appropriate hypothesis for testing you whether whether there was a significant difference in the length of picture run between the theater in Southeastern District and all the America other districts. So you can understand by reading this line that it is two-tailed test. You can understand there's no more than or less than or greater than increase decrease sign. Here you just need to prove that is this mu, is that not equal to 81.5. So whether there's significant difference, this is what you need to. So I hope you are understanding. Whenever you do ANOVA, whenever you do chi-square, everything is two-tailed test only. In Z and T only will fight to see is it one tail or two tail. Otherwise, in ANOVA chi-square, we don't need to worry about all that. Okay. So if you see in this problem, if you see that this is the problem of two-tailed test. This is the problem of two tail test. This is a problem of two tail test. So because this is a problem of two tail test, it will have two alpha value. So it have two alpha value. You can see the alpha is 1%. Alpha is 1, right? Alpha is 1% means, so this will be alpha by 2 here, and this will be alpha by 2 here. So alpha is 1%. So alpha by 2 will be 0.005. So the rejection, this area will be 0.005. This will be 0.495, right? 0.495 or 0.495, correct, right? This will be 0.495. This will be 0.005. So your rejection region is, this is your rejection region. This is your rejection region. So you get the alpha value as 0.005. So your acceptance area, if you see your acceptance area here, that would be 0.495. Your acceptance area is 0.495. So now what you do, under the normal distribution curve, you can find the z value corresponding to 0.495. So use find the acceptance value 0.495. 1 minute. So now what you do, open the normal distribution table. You ask for normal distribution table, see the area called 0.495. 0.495, see the value called 0.495. Guys, I think you can see here 0.495 here. At what value? 2.5, 2.5, 2.5, 2.55, 2.5, 2.57 or 2.58. So 2.57 or 2.58. You do one thing, guys. Open normal distribution table in your mobile or laptop, whichever platform you are using right now for interacting in the class. Please open that from there and please see the value 0.495. So the z value corresponding to, the z value corresponding to the z value corresponding to Z value corresponding to 0.495 is actually 2.58. So everyone please open normal distribution table. So everyone open normal distribution table. It would be better if you look into your own platform. So see the value corresponding to 0.495. The 0.495. So you get a value called 2.58. You will get the value called 2.58. So you'll get the value called 2.58. Everyone please see. Ask me if anyone have any doubt. So the Z value corresponding to 0.495 is 2.58. So if you see in this problem, if you observe in this problem, your population mean is given to you. The population mean is given to you as 84. Okay, your population mean is given to you is 84. So, so the two acceptance region will be here. So if your value lies in these two region, you will accept the null hypothesis. If your value lies between this and this, if your value lies between this and this, you will accept the null hypothesis. So now what I'll do, I'll find the value of x1 and x2, and if the sample if the sample mean if sample mean lies between if my sample mean lies between this x1 and x2, between x1 and x2, then I will accept the null hypothesis. Then I will accept the null hypothesis. Very simple. Nothing can be more easier than this. Then I'll accept the null hypothesis. Very simple. So now I have to find the value of x1 and x2. So I have to find this value. To find this value x1 and x2, I'll find this value x1 and x2. Now I'll find this value x1 and x2. Okay, so and if my thing is that if my sample data, if it lies between that range, I'll accept the null hypothesis. So how will I find the value of x1 and x2? For that, I use a formula mu plus minus mu is 84, and your standard error, and you get the z value corresponding is 2.58 sigma by root n. So I'll use this value x1 and x2, that would be 84 plus minus 2.58 sigma. What is your sigma here? Sigma is 10, right? What is your sigma? What is sigma here? Sigma is 10 and n is 75. Sigma is 10, n is 75. Sigma is 10, n is 75. So you can solve this. So the value of x1 and x2, what you will get, that is 84 plus minus 2.58 into 2.58 into 10, I can write is 25.8, divide by root 75. What is root 75? You can find the value root 75. What is the value corresponding to root 75? So you can open a calculator. Root 75 will be 8 point something. So the root 75 will be 8 point something. Root 75, that is 8.66025454. So this is 8.66, 8.66, 8.660254, 0254. So you can divide 25 by 8, 25 by 8 by this value. So you'll get 2.9791. So you'll get x1 and x2 value as 84 plus minus, you'll get is 2.2 2.9791, 2.9791. So you'll get the x1. So your x1 value is 84 minus 2.9791, and your x2 value will be 84 plus 2.9791. So you'll get the x1 and x2. So what are the values? So 84 minus this, 84 plus this. So 84 minus this, and 84 plus this, 84 plus this. So you'll get 81.0287, 81.02 The minimum or maximum is 86.9791. If your mean sample mean, if that is between this, you'll accept the null hypothesis. What is your sample mean here? So your sample mean is 81 point. Your sample mean is 81.5. You can see this 81.5. So you can, I hope you're understanding. So this is what you're getting. This is 81. This is 81.0287. This is 81. So this you're getting is 81.02. This you're getting is 81.02. You're getting this is 86.97. This you're getting is 86.97. And your sample mean, what is your sample mean? Sample mean is 81.5. Your sample mean is 81.5. Now you know that 81.5 is between 81.02 and 86.97. It means you'll accept the null hypothesis. Okay, so it means if you're accepting the null hypothesis, so what is your null hypothesis? That I'm gonna write it. So this is the other way you can get the same answer. This is the method 2. So now I just did this problem by method 2. I hope you understood this. So you can either apply method 2 or method 1 to get the answer for the same problem. So whichever you like, you can use it ultimately to get the answer. Here, if you see your null hypothesis, what is your null hypothesis? Here, if you see what is your null hypothesis, what is a null hypothesis? Here you can write that in null hypothesis I can write there is no significant there is no significant there is no significant difference there is no significant difference in the length of picture in the length there is no significant difference in the length of picture in the length of pictures run between in the length of picture runs between whatever is given. You simply write there's no significant difference in the length of picture run between theater in south eastern district in southeastern district with respect to America all other districts with respect to America's other districts with respect to America's other theater America other okay. So this is your null hypothesis where you write h naught is equal to mu is equal to 84 days. This you write as your null hypothesis. Then I'll write my alternative hypothesis. Then I'll write my alternative hypothesis. Then I'll write my alternative hypothesis. In null hypothesis, I wrote there's no significant difference. In alternative hypothesis, I'll write there is a difference. There is a significant difference. There is a significant difference. There's a significant difference between there's a significant difference between the length of there's a significant difference between the length of between the there's a significant difference between the length of picture runs the length of pictures run the length of picture run between between the theater of southeastern district between the theater in southeastern district between the theater southeastern district between the theater and southeastern district with respect to with respect to with respect to America's other district with respect to America's other district where you write your alternative hypothesis where you write h1 is equal to mu is not equal to 84 days. So in null hypothesis, when you write a null hypothesis, in null hypothesis, you write that your mu is equal to 84 days. In alternative hypothesis, you write your mu is not equal to 84 days. I hope you're understanding. We are doing two-tailed test here. So in one tail test, we use greater than or less than or increase or decrease. In two tail test, we try to work on only one possibility: is there a significant difference or not? So once you understood this, then I'll find the calculated z value. Then I'll find the calculated z value. I'll find the calculated z value. For that, I'll use a formula x bar minus mu divided by sigma by root n. So x bar is 81.5, mu is 84, sigma is 10 divided by root n is 75. So you simply apply that formula. If you apply this formula, you'll get minus 2.5. So you'll get minus 2.5 divided by 10 by root n. Root 75 is 8.66. 8.66 0.250.254. So once you do this, you will get the value is minus 2.5 into 8.66 0.254 divided by 10. So you can solve this. You will get the calculated z value. So this is what. This 2.5, 25 by 100 means divide by 4 means minus 2.1, 26, 26 means 6 za, 26, 6 za, 25 za, then 0, 6, then 3, then 5. So you'll get this value. So you can check this value. So this, whatever the value you get, this into 2.5 and divide by 10. So you can check, you'll get 2.165064. 2.165064. So you can see this. So this is your calculated Z value. This is your calculated Z value. So you get this as your calculated Z value. So you simple calculated Z value, very simple formula. This is the formula. So X bar is the sample mean, mu is the population mean, sigma is your standard deviation, population standard deviation, n is root n. So you just need to use this formula. Once you use this formula, you will get the calculated Z value. So whatever the calculated Z value, I'll compare this with theoretical Z value. Now I'll find the determine the theoretical Z value. Theoretical Z value, I believe already I have calculated, which is equal to 2.58. So you can see those theoretical Z values 2.58. I hope you remember how I got 2.58, because I have drawn the normal distribution curve. I have drawn the normal distribution curve where zero point 0.5 area lies on left hand side, zero point 0.5 area lies on right hand side. Okay, so okay, then what? Your rejection region was 0.05. This was 0.495. The rejection region was 0.005, and this was 0.495. 0.495. Your This is 0.495. This is 0.005. This is your rejection region. This is your rejection region. So the value corresponding to Z value corresponding to 0.495 under normal distribution table. I hope you remember we got the value called 2.58. So 2.58 is the typical Z value, and 2.165 is your calculated Z value. So now since the calculated Z value, since the calculated Z value is less than the, since our calculated Z value is less than the theoretical Z value, theoretical Z value, so it means we will not reject the null hypothesis. It means we will not reject the null hypothesis. Not reject the null hypothesis. So if you are not rejecting the null hypothesis, means what? It means what that mean? That mean that what that mean? That means that there is no significant difference. It means there is no significant difference. It means there is no significant difference in the length of. There is no significant difference in the length of. There's no significant difference in the length of picture runs the theater of southeastern district, in the theater of southeastern district, with respect to America's other district theater, with respect to America's other district theater, with respect to America other district. Here everyone. So we are accepting the null hypothesis in this problem. So this is what you need to do. If you get one mean Z test problem, if you are getting one mean Z test problem, so you need to do like this way. Anyone, any doubt, any question you want to ask from me? So I'll forward you this worksheet. So around for one mean Z problem, so you have around 5 problem. You can solve this problem. So it's your wish. Whenever you want, you can solve this problem to understand this topic in much more better way. Anyone, any doubt, any question? I believe you have understood what all I have done in this session. So if no one have any doubt, then I like to wind up the class. Anyone, any question you want to ask from me before I wind up the class? Anyone, any question you want to ask from me? Any question, anyone? Those who are trying to join now, so it would be difficult for me because I'm winding the class. So anyone, any question? Anyone, any question? So if you have understood, no one have any doubt, then I like to wind up the class. Thank you everyone. See you all in next class.